University now.
And we're live. Let's do this. So the first page is vectors. Okay?
Am I on the right page?
Here it is. So hopefully by now you know what stuff is. Let's go. I don't have time. We're going to find the magnitude and tell which ones are parallel. Remember, I'm going to make you a smaller quiz, or sorry, test. I'm going to make a smaller test tomorrow for you guys than the review guide. Yes, it is thick with 4 C's. However, stop talking. Thick with 4 C's, it'll be smaller tomorrow. We're talking at most 1 question per page, which means 19 questions max. It will be less than that. They will be simplified, meaning that instead of giving you all these vectors to figure out whether they're parallel and what their magnitude is, I might give you 2 and say, are they parallel? Yes or no, and you'll have to be able to prove it.
Why is it not a quiz?
Okay?
Why is it a test?
Can you shut up? So, you're also going to have to do a lot of writing. We're going to get into that. Make sure you have your phones ready to take pictures. I will be going quickly. I would encourage you not to write this down, but instead, follow along.
Thank you, channel.
Well, that's what we're doing. I have it live right now. You can write it down if you want, but if you can't keep up, that's why. You're not meant to, okay? Here we go. Alex, let's go. So, here we go. To find out whether they're parallel or not, checking out V, we're going to compare its components. We're going to think of it as slope. That's 4 over -2 for rise over run. That simplifies to -2. If they have the same slope, they're going to be parallel. So I'm going to find another one that has this slope. Turns out none of them do. I'm going to go to A. -3 over 3 simplifies to -1. Notice that 3 over -3 for vector D also simplifies to -1, which means that A and D will be parallel. So I'm going to write that like this. Vector A is parallel to vector D. Are there others that are parallel? Probably. Maybe, maybe not. See, off the top of my head, -2, 4, 4, -1. Doesn't look like any of the other ones are parallel, but you can correct me if I'm wrong. To figure out what their magnitude is, we're talking about their length. In other words, we're talking distance. In other words, we're talking Pythagorean theorem. So we're going to take their components, which are going to be the legs of the triangle, and the vector is going to be the hypotenuse, right? So to figure out the length of the hypotenuse, the length of the vector, we're going to do Pythag to these guys. So to figure out V's magnitude, this is the symbol for magnitude. No, you do not have to write it. But the magnitude of vector V is going to be -2 squared plus 4 squared,
That should be easy.
all rooted. Does everybody see why I got those numbers, where I got them from, and why I'm doing it? Cool. -2 squared is -2 times itself, so 2 negatives make a positive. 2 times 2 is 4. 4 squared is 4 times 4, which is 16. So in total we have root 20. Root 20 does not simplify, so leave it like that, root 20. If it was root 25, you could do something. If it was root 16, you could do something. Or root 20 is going to be a number between 4 and 5, so 4 point something, just circle. That is the magnitude. Questions on how to find magnitude? Questions on how to figure out whether they're parallel or not? Fantastic. Moving on. That's right. Number 2, here we go. This is where things get a little hairy. We're going to graph this line right here, and that is going to be our mirror. This point right here is the point we're going to reflect. In order to do this, we're going to have to find a perpendicular line and all that jazz. So buckle up. Slope-intercept form. Y-intercept is -2, so it hits there. What's our slope? 1 over 1. There's a 1 in front of that x. So we're going to go up 1 over 1. And that's going to be our line. So there's the mirror. Here's the point we're going to reflect. 2, -7. 1, 2, 3, 4, 5, 6, 7. That's A. Now we know all reflections happen perpendicular to the mirror, which means we're going to have to find the perpendicular line that goes through this point. Perpendicular lines have perpendicular slope. So if the slope of this guy is 1 over 1, what's the perpendicular slope? -1 over 1, right? We flip it. 1 over 1 turns into 1 over 1 after we flip it. Stays the same, right? And then we negate it. So it's going to be y equals -1 over 1x. I'm just going to write that as -x. Now the y-intercept for this equation is going to be the y-intercept that makes it go through this point. So in order to make sure this line does go through A,
Did you,
He's in the wrong spot.
yeah, it's supposed to be -2, -7.
oh, I read +2. My bad. -2, -7. 1, 2, 3, 4, 5.
I was kind of confused.
Good job. Thanks for thinking. All right, so we're going to plug in -2, -7 into this to figure out what B has to do. Sounding familiar?
Yes.
Yeah.
Okay, cool. So we're going to plug that in here. Negative 7 for y. And when we plug in something for x or y, make sure you wrap it in parentheses. Cannot hurt if you know what you're doing.
Yep.
So when we plug that in, we're going to have two negatives there. One from the number and one from the slope after we flip it and negate it, right? So that's going to be a positive 2. Which means we're going to subtract that, and b is going to be negative 9. So our perpendicular line is y equals negative x minus 9. How do you feel so far?
I remember that.
We found the perpendicular. Flip and negate the slope. Solve for b. How do you feel? Decent? Okay. Now let's graph that line. What's the y-intercept of the red line?
-9.
Negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is the y-intercept. And our slope is down 1 over 1. So down 1 to the right 1. Notice that that's going to make it go through point A, which it better.
We do no station, pause for station identification.
There's our line. Do they intersect at a nice point?
Yeah.
No, they don't. Which is all the reason more why we need to do algebra to figure out what that point is.
Oh.
So, how do we figure out where two lines intersect? It's where they agree,
Midpoint.
right? How do we figure out where two lines intersect? Bare hands.
Equal to each other.
Yeah, we said they're equal to each other, right? The idea is this, pay attention. Y equals x minus 2. So if y equals x minus 2, can't I substitute that down here?
Yeah.
Right? I can. So I'm going to do that. I'm going to put x minus 2 in for y. And I'm going to solve for x. And where I find x is where they both agree. They're only going to agree at one spot. And that's going to be where the midpoint is, between a and where a prime is reflected to. So let's solve. I'm going to move my x over here and get 2x, move my negative 2 over there and get negative 7. Oh no! It is going to be a gross point. We divide by 2 and we get negative 7 over 2. Negative 7 halves. Looks right. 2 halves, or 4 halves, 8 halves, I'm sorry, 1, 2, 2 halves, 3, 4 halves, 6 halves, 7 halves to the left. Yep. So our midpoint is going to be negative 7 halves, comma something. How do I find the comma something, the y value?
This is a simple.
Bare hands again.
You plug it in. You plug x into one of the equations.
Either of the equations, right? Because it's where they agree. And if they didn't agree, they get different answers. But since they do agree, you're going to get the same answer. It doesn't matter which one you plug it into. I'm going to plug it into the top one because that just looks a little bit easier, right? So I'm going to do that. I'm going to take y equals, and I'm going to plug in negative 7 halves for x. Minus 2. So now we're doing subtraction. We need common denominators.
I mean,
So negative 7 halves minus something else with halves is what we need, right? How many halves are in 2? 4 halves. Check it out. What's 4 divided by 2? 2. So did we change the problem? No, it's the same thing, just a different way of looking at it. Now do they have the same denominator?
yes.
Then we can combine them. So I've got negative 7 halves, and I'm subtracting 4 more. I'm going to have negative 11 halves.
This is the same as the one today.
Very similar. Numbers can change. Remember, I smash all your tests together, and that's what I do to make this. It's super similar.
Yeah, I was gonna say because -7 and -11 over. They were both over 2. They were.
Super similar.
Yeah.
So, here we are. How do you feel? Set them equal, solve. Sometimes you're going to have to get common denominators when you have fractions, right? We'll review common denominators in a second, okay? So that's the midpoint. That's halfway between A and wherever A prime is going to be. Because all reflections are the same distance on both sides of the mirror, right? So now we're going to use that and use midpoint formula to figure out where A prime is. Normally, midpoint says take your 2 outer points, average them to get the midpoint, right? But now we know one of the outer points and the midpoint. We're going to use that to find the other outer point, A prime. So, midpoint formula, what is it? What's the midpoint formula?
X.
Katie?
Average of the x's and average of the
Average of the x's, average of the y's. When we average stuff, what do we do? When we average something, what do we do? Add them up and divide by number of pieces. Very good. So midpoint formula is the midpoint, which we know,
It's Kinsey.
thank you, the midpoint, which we know is going to equal the average of our x's and average of our y's. Now we know one of our x's and y's because that's A. We don't know the other. That's the other one we're looking for, right? So the one we're looking for is x2 and y2. And the one we know is A, which is -2, -7. You with me? So I'm here. We'll pause for station identification. here I am, midpoint formula. There's my midpoint that I found earlier. There's A, and here's going to be A prime, right? X2 and Y2. So we're trying to find what X and Y are. So we're trying to solve for X and Y. We're trying to get X and Y on their own. So ignore this part for now. We know that this part here should get us -7 halves, right? So they equal each other. So I'm going to write that. -7 halves should equal X2. What's a better way to write plus a -2?
Negative.
Just -2.
Just minus.
We also know that this part right here, Y2 plus a -7/2, should equal -11 halves. So I'm going to write that. And of course, the easier way to write that is to do it Y2 -7/2. So now we're going to solve for X and Y. X over here and Y there. So ignore this for now. X2 has two things bothering it. Divides by 2, we know how to solve for that, right? We know how to get rid of that. And a -2, we know how to get rid of that. Let's get rid of the division first, make a better world, like bring people together. That's what we're all about. How do we get rid of division? Division is divorce. How do you cancel divorce?
Multiplication.
Multiplication. Right? So we're going to multiply by 2 to both sides. Now check it out. What happens? We have -7 divided by 2. And we're timesing it by 2. Don't division, multiplication, cancel. So if we divide by 2 and times by 2, really what we get is -7. And over here, the divided by 2 is gone because we multiplied by 2. Yay! Thanks, Mr. Mac, for making a problem that cancels the fractions. Did everybody see how I got from here to here? Times by 2 to both sides, the division goes away. It was a coincidence. Now we're going to add 2, and we find out that X2 is -5. So A prime is going to be at -5 comma something. The other something's over here. Let's times by 2 to both sides. I get 11 negative. And then Y2 minus 7. So now I add 7. -4 equals Y2. So A prime should be at -5, -4. Let's graph it. -5, 1, 2, 3, 4, 5, -4, 1, 2, 3, 4. It's on our red line. Oh my God, and it's the same distance on both sides. We did it!
That was excessive.
Shut up. Welcome to math class. Questions on this? Graph your original stuff, flip and negate the slope, solve for B, find the midpoint, do midpoint formula, find the reflection point.
Is all this gonna be on the test tomorrow?
Yeah.
There's like.
Danny.
Next
We
question.
already had a
Go ahead.
I know it.
You okay, Alex?
It's the test. Go
No?
over,
All right. Take your time.
Where's he going?
Take care of business. 3, same dumb crap. So we're gonna skip it. 4, same dumb crap but harder, because you're gonna have to get common denominators at one point, right? Let's skip it and let's just talk about what makes this one harder. The common denominators.
There, yeah.
So, actually, yeah, we'll do it up here. All right. See it sort of? Okay. Let's talk about common denominators. First of all, let's do the easy thing. Do we need common denominators? No, it's multiplication. Multiplication is great with fractions. This just means 2 divided by 3 times 2. Do it in any order you want, right? How about we do 2 times 2 first? What's that? 4. Now we divide it by 3. What's 4 divided by 3? 4/3. Fractions are division for lazy people. What's 4 divided by 3? 4 over 3. What's 5 divided by 2? 5 over 2. 5 halves. What's 8 divided by 2? Well, it's 4, but you could write it as 8 over 2 and then simplify, right? That's all this means. You have 2/3 and you're doubling it. Now you have 4/3, right? Makes sense to me. You can also divide first. What's 2 divided by 3? Well, it's 2/3. Now we have to times it by the top. What's 2/3 times 2? Well, it's 4/3. Same to the crap. How do you feel about multiplication? These times by the top, divided by the bottom is good. Make it a little bit harder. Do we need common denominators?
Yeah. No.
Why do we need common denominators?
I mean, we don't need it, but.
It's multiplication, right? Just do it! So, it's 3 divided by 4, right? When division, we don't need common denominators, right? If I give you a bunch of numbers, we don't have to figure out common denominators for them all. You just do it, right? 3 divided by 4 divided by 3 times 2. Oh, God, right? We do it in any order we want. Let's do 3 times 2 first. What's that? 6. Let's divide 6 by 3 now. What's that? Oh, it's 2. And then we have to divide it by 4. So 2 divided by 4. What's that reduce to? A half. Any order you want as long as you do it. Multiply these, divide those. Now you might be thinking, why not just multiply across? You can. Not like this. We're not cross multiplying. That does not exist. It's a lie. It's stupid. They should have never taught you that. We multiply across. What's 2 times 3? 6. What's 3 times 12? 12. Why does this work? Because division on the bottom is just multiplication. We're dividing by 3, dividing by 4. Check it out. If I have an object and I divide it into 3 pieces, right? So I divide it by 3. Now I'm going to divide it by 4. 4 pieces, 4 pieces, 4 pieces. How many pieces did I divide it into? 12. Dividing something by 3 and then dividing by 4 is the same as dividing by 12. Dividing by 3, dividing by 4 is the same as dividing by 12. So I took 2 and 3 and multiplied them because they're in the top, right? That's what you do. It's 6. And then I divided by 3 and divided by 4. Otherwise known as just dividing it by 12. 6 divided by 12, a half. How do you feel about multiplication? We got options. Times by the top, divide by the bottom, or you can just multiply across. It's the same thing done. And now you know why multiplying across works. Because we're dividing by 3 and dividing by 4, which is the same thing as dividing by 12. Let's talk common denominators. Do we need common denominators? Yes, we are adding. They're not the same thing. You can't add apples and oranges, right? So, how many thirds? We need common denominators, right? How many thirds are in the number 2? 6 thirds. Right? There's 3 thirds in 1. 3 over 3 is 1. So twice as many thirds in 2. 6 thirds. Check your work. Is 6 divided by 3 2? Yeah, so we didn't change the problem, we just made it look different. And now we see they're talking about the same thing. If I've got 2 thirds, and now I've got 6 thirds in addition to that, right? I got 6 thirds more. How many thirds total do I have?
8 thirds.
8 thirds. That's it. Make it a little bit harder. Do I need common denominators?
Yes.
Yes, we're adding, right? Adding or subtracting, we need common denominators. What's the common denominator going to be?
12.
12.
8 over 12.
When you multiply by 1, does it ever change anything? No, it always keeps the same. Well, I need to make that 3 to 12. So what I did is I multiplied by 4 in the bottom, right? Is that allowed? No, because it changes the problem, right? However, if I multiply the top by 4 as well, it will be allowed. Why is that allowed if I do it to both the top and the bottom? Why?
Because it stays the same, basically.
Why does it stay the same?
It's like the same amount as it was before.
How do you know?
Because if you divide it back, you can
You
divide
can
it.
do all that work. There's an easier way to know, though. Who sees it?
They're equivalent.
Say,
4 over 4 is 1.
I'm multiplying by 1. And multiplying by 1 doesn't change it. 4 divided by 4 is 1. So you multiply the top and the bottom, it's just like multiplying by 1, which doesn't change anything. It just makes it look different, right? So I multiply by 4 here and 4 there. You can check it. 8 divided by 12 does simplify to 2/3. Right? It didn't change the problem, just made it look different. 4 over 4 is multiplying by 1. So it's allowed. Now this side I'm not going to multiply by 4 over 4 because I want that 4 to be a 12. What did I multiply 4 by to make it a 12? 3. So what I did here is I multiplied this by 3 over 3, which again is multiplied by 1. So it's kosher. What's 3 times 3? 9. So how many 12s do I have here total? 17 12s. Whoa! Oh man! It's falling apart just in time for finals week. He's crumbling under the pressure. Wow. How you feel? Common denominators for addition and subtraction. Do we need it for multiplication? No. Multiply across. Right. Skip 4, skip 5. Let's look at SIX. S-I-X.
What?
I have a very depressing story about moonwalking sometime that I'll share with you, but not today.
I mean, it's a lot of stories.
Translation. We're just sliding from A to A prime. We go in the direction of primes, right? All of them are going to have the same vector. What vector are we using to translate from A to A prime? Looks like we're going 1, 2, 3, 4, 5, 6 to the right, and 4 up. Which means our rule for everything is just what? X, what? Plus 6, and Y plus 4. That's it. Remember when this was hard? Here's what I would do. I would write down A, B, and C here. I wouldn't even bother looking at those. I would just add 6 and 4 to them all, right? Save me a lot of time. B's really easy. It's 0, 3, right? Well, after I add 6 and add 4, I've got 6, 7. Why count that, right? Be confident. Don't goof up basic math. You'll be all right. I know, right? Do it for all of them. 7, same dumb crap. What's the vector we're using? Well, from B to B prime, it looks like we're doing 1, 2, 3, 4, 5, 6 to the right, and 4 up. Wow. It's the same rule, isn't it? Did I count wrong? I hope I counted correctly.
It's 7.
Is it 7?
Yeah.
Darn!
Ah,
It's 7.
it's okay.
Minus a half. If I retake it, I don't even have to do it. Questions, comments, concerns? How are we
Other
doing?
than for you.
Write down your coordinates, do the rule. Turn the page. Number 8. Reflection. But look, it's the easy kind. We don't have to do all that stupid perpendicular line equation nonsense, right? It's over the x-axis. It's what kind of a flip when we flip it? Horizontal or vertical flip? Vertical flip. So if we're vertically flipping, which variable gets negated?
Y.
The y. So x negative y. And because it's the x-axis, that's all it is. It's a basic reflection, right? So it has a basic rule. B is 3 away from the line of reflection, so it's going to be 3 away after we reflect it. A is 6 away from the line of reflection, so it's going to be 6, 1, 2, 3, 4, 5, 6 after we reflect it. There it is. Or you could write down the coordinates and negate the y, whatever. How do you feel?
Pretty good.
Why?
It's the dilation thing. That one you made us do yesterday.
I know, right?
At the
9.
End. That sucks.
Is this a basic reflection?
Yep, right
Sort of.
there it is.
Kind of, but it's not the y-axis, right?
There it is.
So we're going to have a little bit of adjusting to do. You don't remember this, I'm sure, but I'll show it to you and you'll remember. Here we go. Let's just reflect it using logic, right? The mirror is going to have the same distance on both sides to the reflection, right? So let's look at A. A is 1, 2, 3, 4, 5 away from the mirror. So when we flip it across this way, it's going to be 5 on this side. 1, 2, 3, 4, 5. There's A prime. What kind of a flip is that? Horizontal or vertical? Horizontal, so we negate the x. But here's the problem. Here's the problem. I know what you think, but here's the problem. Okay? A's coordinate is negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. And 1, 2, 3, 4, 5, 6 up. And if we just negate the x, like we think our rule is supposed to be, does that get us A prime's coordinate, which is 0, 6? No! That gets us 10, 6. Right? So what do we do? Well, after I negate the 10, it becomes positive 10, right? Well, let's slide it into place. If I'm at positive 10 now, what do I need to do to make it 0? I subtract what? I subtract 10. Right? I negate it, it becomes positive 10. And then I subtract 10 to finish it off. Finish him. Right? Mortal Kombat. Anybody?
Oh, yes.
Oh, yes. Katie, who you main on Mortal Kombat?
What?
Who's your main character?
Baraka.
Nerd.
I've always been a Scorpion fan. Because I'm basic. I know.
Sub-Zero.
You're basic. I know. So, to adjust for this, we have to subtract 10. That's it. Another way to think about it, it's 5 away from where it's supposed to be, so we need to slide it 5 to the right, so we do negative 10, it's double because it's symmetrical, something like that. Don't worry about that. Okay? Just don't worry about that. Ain't no thing. Okay? Just do the thing. How do we feel about that? Apply your basic rule, right? Horizontal flip, negate the x. And then after we do that, how do we need to adjust it? Well, it's positive 10 now. I need to subtract 10 to get to 0, so subtract 10. Y stays the same. Turn the page. Next one. Oh God, it's a rotation. I have to draw all those L's? Why? No. Don't draw L's. We know the rules now. First of all, is this rotation centered at 0, 0? No! We're going to slide it to 0, 0. So what vector am I going to use to slide it? Looks like 3 to the left and 2 down. There's the vector I'm going to use, right? They want us to rotate it 180 degrees. What's the rotation rule for 180 degrees?
Negate X and Y.
Negate x and y. Why?
One.
Because if we're here, double positive, and we rotate 180, here's our L. Horizontal becomes vertical after 90, goes back to horizontal after 180. So it's here now. Vertical turns horizontal, then goes vertical again. So it's here. Did the horizontal change to vertical? No, it stayed the same. Horizontal stayed horizontal. So x stays the same. Did vertical stay vertical? Yeah, so y stays the same. They don't flip, right? But what does happen is we negate both. How do you feel about that? Are you understanding why the rule is to keep the x and y in the same spot? Do you see why we negate them both?
Yes.
Awesome. Because you're going to have to explain it in words.
Which are hard, man.
Then we slide it back. 3 to the right and 2 up. So what's our rule going to be? I'll tell you what the rule is going to be. First, we start out with x and y. Then, we subtract 3 and subtract 2. Now, because x and y stay in the same spot,
Wait.
what?
Isn't it like the vertex? Didn't you do them backward? Because it's going negative, so you switch it.
3 to the left, 2 down.
Yeah,
That's
but
the
for the
first
first one, isn't it the opposite?
Why would it be?
I thought it was.
I'm sending it 3 to the left and 2 down because I want it to go there.
Oh, then you shift it back.
Yeah,
Alright,
yeah, yeah.
alright,
Good,
alright.
yep, good. So, we start there, then we negate both the x and the y. So I'm going to draw a little box around this so we show that that was done first. And then we negate them both. Boop, boop. And then, as typical of Mr. Mac, I forgot to leave room for my shift back. So I'm going to add 3 to this side and add 2 to that side. So that's the overall rule. Is it okay that I wrote it like that? Let me see what's going on here. I will have mercy upon you if you have mercy upon me.
Yeah.
Until I have it right when I want you to have it. Right. So here's what I would do. Instead of drawing all your L's, write down the coordinates of all these guys, right? Like E is 0, 0, right? Let's plug that into here and we get E prime for free. So let's plug in 0. 0 minus 3 is? Negative 3. Negate it. Add 3. So E prime is going to be at 6. Let's plug in 0 here. 0 minus 2 is? Make it negative. Add 2. So E prime is at 6, 4. Which is how tall I am. 1, 2, 3, 4, 5, 6. 1, 2, 3. There's E prime. Do that to all your points and then connect the dots and make it look like that.
Alright,
Make sure E is connected to DNA. Don't connect like this. How you feel? Okay?
Yeah.
Turn the page. Number 11, 90-degree counterclockwise rotation about R. Let's practice again. Let's find the rule. I'm going to send R to the origin. So that means I'm going to send it 4 to the left and 1 up. Then I'm going to do a 90 degrees counterclockwise rotation about R. 90-degree counterclockwise. What's the rule for that? I forgot, but I can figure it out. Because guess what? 90 degrees counterclockwise is this way. So it's going to end up like this. Did the horizontal stay horizontal or did it change? It changed. So x and y are going to switch spots. Do we negate anything? Positive, positive, negative, positive. Which one do we negate? The first one. The first one. Okay? So we're going to negate the first one, and x and y are going to switch spots. Then we're slide it back. 4 minus 1. So what will the rule be? Well, because x and y switch spots, I'm going to have to write a bunch of steps, because that's how writing works. I can't erase it. I write it. So, first thing we're going to do is take x and y. I'm going to subtract 4, and then we're going to add 1. Boop, boop. Now I got to flip them. Crap, I have to write it again. So I have to flip them and negate the first one. So I take the whole thing over here, y plus 1 all together, and x minus 4 all together, and flip them. Then I negate them both. Sorry, not negate them both, negate one of them. Ignore the purple. Are we good? Flip them, negate the first one.
Yeah.
See how the y plus 1 goes all together? It's not just switching the variables, it's switching the whole thing. Okay? Then we add 4
Hang on.
and subtract 1. Yes.
So if it's a clockwise rotation of 90 degrees, do we keep the x and y the same?
X and Y switch for clockwise as well, because that L is going to swing down here, like that. See how horizontal became vertical?
Yeah.
Vertical became horizontal, X and Y switch. Now for this one, the difference is
Alright, yeah.
we negate the second.
Alright.
Oh man, I almost flipped it onto the Alright. Then I would take those coordinates and plug them into this and get my new coordinates, right? That's what I would do. Or you can draw those up to you. Ready to turn the page?
No.
I woke up at 2 a.m. this morning. I went to bed at 8 because I was too exhausted to do any more work. So I woke up at 2. The heat in my car still does not work. So I had to drive my windows down and looking out the side so I can see out the front because it won't defrost. Do not advise. I bought a little thing. It's a little like blow dryer. It sucks. Hey, it couldn't warm your hands.
My dad did.
I paid $20 on Amazon for it. It can't warm your hands in the car, let alone defog my windshield.
I can imagine what that looks like.
My
Yeah,
dad.
what did Bartos say about that? I don't know if that's the rules of the road right there. All right, so 12. Explain the rule for a clockwise 90-degree rotation, counterclockwise rotation, and 180-degree rotation. I'll pick one of those for you to explain on the test.
180.
Okay? All of those is what I explained. Here's the words I would use. Right here. You may take a picture.
Whoa.
I explained one of them. I explained this one, 90-degree clockwise. It's the same dumb crap for counterclockwise, just reversed. And then 180 I'll explain in a second.
So
I also have a
face
present
out
for
of
you.
your picture.
Yeah, you should take a picture because it's in color.
Oh.
But here this is printed out in black and white. And again, I'll explain one of them. So here's what the words say. So listen to my words as I pass this out. For a 90-degree clockwise rotation, the blue part goes from horizontal to vertical. Do you see that? How the blue part goes from horizontal to vertical?
Yes.
Good. The red part is pointing up. It's going from vertical to horizontal. So X and Y switch.
Wait, you just gave it to me?
The original X becomes negative. So look at that blue part. It's pointing to the right originally
Wait, why did I take a picture of this?
because it's in color. And then it swings down and points down. So we go from pointing right to pointing down. Right is positive. When we go to pointing down, it switches to negative, doesn't it? The red part is pointing up, so it's positive. When it turns, it's pointing to the right, which is still positive, which is why the Y doesn't change its sign.
Yeah.
For 180-degree rotation, the blue part stays horizontal. And the red part stays vertical, so X and Y don't switch. Both get negated because the blue part was originally pointing to the right, but now it's pointing left. So it went from positive to negative. The red part is pointing up, but now it's pointing down. So it went from positive to negative. So we changed both the signs. That would be my explanation. 14, I didn't use words, but you're going to. Here they are. When we flip across the y-axis, what kind of a flip is that? Horizontal. So we negate the x. That's what I'd say. When we flip across the x-axis, what kind of a flip is that?
Vertical.
Vertical. So we negate the y. That's the explanation. That's it. You know this crap. Just put it into words. If you need help, I can help you. With the wording. You need to know it, though. Right? Vertical flip, negate the y.
Alright.
Horizontal flip, negate the x.
So, when flipping over the y-axis.
No. Explain how a rotation about an arbitrary point works. Here we go. Take a picture if you want. It's on there. It's not in color. You don't need to. Ha. So, since an arbitrary center complicates things, it is easiest to adjust everything to the center. Right? When we have an arbitrary point, it's not on 0, 0. It makes things messy. So we slide it to the center to make it an easier problem.
15 is not even on.
Then we do our rotation, which we have explained thoroughly up here, right? And then we slide it back. So here's what I would say for number 15. It's not number 15 in the guide. This is from your review guide from the last quiz. Okay? I'm recycling it. Okay? We slide it to the origin, make the problem easier. We apply a basic rotation, and then we slide it back to answer the real problem. How do you feel about that? That's the explanation. That's why we do what we do. So that takes us through. Oh, here it is. That gets us 12 out of the way. That gets us 13 out of the way. That gets us 14 out of the way. We are now on 15. Dilate each image by the given rule centered at the origin. So, for this one, we're dilating from 0, 0. Yay. So check it out. The rule says negate the x and 3y. So that means, look at C. How far is it away from the origin horizontally?
3.
1 horizontally.
Oh, I think I was thinking.
I know. So 1 horizontally. But we're going to negate it. So instead of going to the right one, we're going to the left one. You dig?
Sort of.
I dig.
C is 3 vertically. But we want to triple that, don't we?
Yeah.
So how far is it going to be apart vertically now? 9. So it's 1 to the left and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's C prime. If you don't like that, write all those points down and then do the rule to it, right? Negate the first number, triple the third or the second number. And then plot your points. Do it for all of them. Yes!
So we don't have to do all the algebra stuff for these?
I don't know what you're talking about.
All the algebra stuff, like the switch, negate, switch back.
No. It's a basic thing.
Alright, good.
Do it. That's the algebra. That is the algebra right there. That's the rule.
That's
You don't have to adjust because it's already on 0.
I get it.
Yay! 16. Are we shrinking or growing?
Shrinking.
We're shrinking. It was a cold day. Water was cold. Seinfeld. Seinfeld? You
No,
seen Seinfeld?
I don't think.
You have a great sense of humor. Katie, we're connecting on so many levels today.
I thought.
George Costanza. The water was cold, Jerry. The water was cold! All right, 16. We're shrinking in the horizontal direction by half, and we're shrinking in the vertical direction by a third. So, check it out. 0, 0 is the center of dilation for this. Let's look at A. How far is A apart from 0, 0 horizontally?
1 and 2.
2. When we have it, it's only going to be
So
apart
it'd
1.
be 1.
A is how far apart vertically? 1, 2, 3, 4, 5, 6. So we're going to third that. What's a third of 6? 2. So we're going to go over 1 and up 2. Again, if you don't like what I'm doing here, write all those coordinates down and then do the math to it and then plot your points. It's up to you. It's up to you.
Alright.
17, you ready? Are we shrinking or growing?
Both.
Both. We're shrinking in what direction?
Or horizontal.
Horizontal direction, x is a half. We're also going to flip horizontally because it's negative, right? Horizontal flip.
Oh,
Hang on.
And then we're growing vertically. Speaking of which, Danny,
Can we go back up to the next question and try B?
back up to the next question. So back to the future. Try B. Sure, we can do that. B is how much to the left?
2.
2. So we have that as 1 to the left.
-1, yeah. So Y.
B is 3 up, so we third that. It's right here. There's B prime.
Uh-oh.
Ooh, gross.
Alright.
it's on the image. Oh my god.
Get over it. Okay?
This guy's insane.
I have to look at ugly things every day.
This guy's insane.
2 a.m.
This one.
Yeah, this is what you get wake up at 2 a.m.
Whoa! All right, so
Driving in the freezing cold.
again, 0, 0.
I can just see his head.
Let's look at B. B is how far away horizontally?
What do you do when a car goes?
How far is it away horizontally? 4. We have that. We get 2, but we also negate it and we get this side. You with me?
Yeah.
What do you think?
B is, I'll start again. How far away is B from 0, 0 horizontally? 4. We're supposed to have that. So 2, and then we negate it.
So the other side.
So the other side, right? Vertical or horizontal flip.
Okay.
B is 3 away vertically, but when we triple that, it's going to be how much away vertically? 9! So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So B prime is going to be at 2, 9. That's convenient. And regular B was at -4, +3. Notice when you have and negate that, you get 2. When you triple that, you get 9. You could literally just write it down and do the math, and then plot your points. A, let's do that. A appears to be at 1, 2, 3, 4, down 3. When we have that, what's half of 4?
2.
Negate it.
-2.
What's -3 times 3?
-9.
So -2, -9. Look, we shrunk it this way by half, and we elongated it this way by 3.
Impressive.
Other than Alex, how you feel?
I feel great. How do you like? What
Isn't it great reviewing this? Because you learned it the first time. It really is reviewing it.
What?
I don't have to reteach it.
What What do you do when a car has to pass you and your head's out the window? Or when a car's going by
Duck.
you? Like, ah.
Dog.
Next one.
That's what my dad had to do.
Dilation at 0, 0. We're trying to find the rule based on they already did it for us. Super duper easy. So check it out. We're going from B to B prime. Don't make the mistake of starting here, right? So how far apart is B from the origin horizontally?
2.
2! And it ends up being only what? After we do the dilation, it ends up being 1 away. So what do? We have the x. B is 1, 2, 3, 4, 5, 6 away vertically. But after we do our thing, it becomes only 3. So what do we do to the y? We have the y. No negatives needed because we didn't flip anything, right? 19. Actually, let's skip down to 20. 20. Oh, God.
This is for you.
Oh no.
I can do it.
All right, here we go. A to A prime. A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away vertically, but after we're done, it's only 5 away. We halved it. Did we flip it?
No.
No, we didn't. A is still top, right? Look at B. B is 5 away, but then it becomes 1 away. So what did we do to the y? We times it by a fifth. We fifthed it. Easy for you to say. Ta-da!
Wait.
Wow.
What if B and D had changed sides?
Negative. Swiss.
X would be negative.
Negative x, exactly.
Yeah.
That's a horizontal flip.
Wow.
Wow!
Wait.
To the page?
Wait.
Wow.
21. Explain the difference between isometric and non-isometric and tell me which type of transformation is which. What does isometric mean? What does iso mean?
Single.
Isosceles thing, right? The same. Iso means the same. What does metric mean? What does that have to do with?
I don't think I'm gonna feel this.
Measure. So same measure, same size. Do dilations keep things the same size?
Yeah.
No, they change it. So it's non-isometric. Dilations are non-isometric. Do rotations change the size? No, they just change the location. Do pushing things, translations change the size? No, right? I push the pen, it's still the same size, right? What about reflections? Do they change the size? Not unless you're in a funhouse mirror, right?
So which one?
22.
That's kind of good.
There is no 22. Look at 23. It says double the x, double the y. So write your coordinates down and double the x and double the y. The rule is going to require you to push c to the origin first. That's 2 to the left and 1 down. Then we're going to double the x and double the y. Then we're going to push it back. Write the rule. The rule is going to be x minus 2, y minus 1. Then we double them. Then we add 2 and add 1. That's the rule. Plug in your coordinates and find out where they go, right? That's what I would do. How do you feel?
Alright.
24. Third the x, half the y. Push c to the origin. 2 to the left, 3 down. Then we're going to have the x. I'm sorry, third the x and half the y. Then we're going to slide it back. 2, 3. Could you write that rule? I bet you could. X minus 2, y minus 3. In parentheses. Third it, have it, add 2, add 3. How you feel? Moving on. 25. The only thing funnier than 24. Find the rule for the dilation.
Oh my goodness.
Push it. 2 to the right, 3 down. Then we dilate, going from t to t prime. Notice that t is 1, 2, 3, 4, 5, 6 away horizontally from c. And it ends up only 3 away. So what do? We halved it. T is 2 away vertically, but it's only 1 away after we're done. So we halved it. And then we're going to push it back. I bet you could write that rule. X plus 2, y minus 3. Have it, have it. Minus 2 plus 3. Rule's done. How do you feel?
Wait. Never mind.
26. Oh God, it's going to take multiple moves. Here we go. Are you ready? First, we got to make it the same size. I'm going to make C 0, 0 because that makes things easy, right? We're going to make it the same size. Notice that this is 4 across, but it's only 2 there. So what are we going to do to the x? We're going to have the x. What are we going to do to the y? We go from 3 to 1. Third it. That's going to put us here. Notice t is 4 and 3 away. So 4 becomes 2 and 3 becomes 1. So t prime is going to end up here. U prime is going to end up here. V prime is going to end up here. W prime is going to end up here. Notice that it's not the right orientation. Top left corner is U. We need it to be V. So we're going to flip it horizontally. How do we flip something horizontally? Negate the x. Now it's here. Then we slide it into place with a vector.
Alright.
Explain dilation by an arbitrary point.
Oh, gosh.
You slide it,
Not prepared.
you dilate it, and then you slide it back.
I'm not
I
prepared.
said it couldn't be done.
I'm ready.
I'm not
Can't
prepared.
believe that took the whole time.
Told you it would.
After this semester's over,
If Danny hadn't have spoken, it would have been right at the bell. That's how it worked out first period. Watch their review if you want something a little bit slower. We took it a little bit slower first period.
Alright.
You guys are more talkative.
Did you even get it done first period?
Yeah, we did. With time to spare.
We got
Like
done
3
too.
seconds.
We got done.
Yeah, you did.
Yeah.
You got this. You learned it the first time. We were just reviewing today. You already know this.
Yeah,
Bare
but
hands.
There was one, like 21.